So just write this down before we move on.
Good evening, sir.
Good evening, how are you?
I'm fine, sir. So, sir, which topic are we doing?
Yeah, we are still on work energy and power. We want to exhaust possible questions that you can have from there.
Okay. So,
So I want you to
um,
write these formulas down, okay? You know, last class we said force can be we said force is mass times acceleration. You can use that formula, but you can have questions where what you are given is power and velocity, and you'll be asked to calculate force. The formula will be power over velocity. I want you to note that, okay? And I also said work done, which originally we said is force times distance, can be said to be force times distance times cos theta. If the applied force is at an angle, you will see it in the question. Once you are given an angle at which the force acts, you cannot just use force times distance. It has to be force times distance times cos theta. Okay. Then according to law of conservation of energy, kinetic energy is equal, the kinetic energy of an object is equal to its potential energy. Don't forget that. Then power, which you already know, I think we used this formula in the last class, energy over time or work done over time. And energy or work done is the same as force times distance. So power can be force times distance over time also. Are you following me? So can we move on now? Can we move on?
yes, sir.
All right. So this is the first question that we are going to deal with. This question says a car. Don't remember that I told you in physics, when you look at a question, don't the first thing you need to do is don't think it's difficult. Just look at the values you are given in that question. Bring those values together. The formula will come to your mind, especially if you have done your study very well. You will know which formula to apply. Now, let's solve this one together. I'm going to solve this now. Please pay attention because I will give you similar questions. These are JAMB questions. These are UTME questions. All these questions that I have here. Okay, so a car traveling at 40 meters per second, that is the velocity. Once you see meters per second is velocity, you are supposed to know that by now. That is the unit of velocity. Meter per second square is acceleration. Meters per second is velocity. So you write it down. You have your velocity now. What else do I have in the question? Produces a force of 200 Newton. Okay, the question has given me force. Force is 200 Newton. 200 Newton. Then what else do I have in the question? Power. Calculate the power of its engine in kilowatts. Okay. Power is not given, it's the unknown I'm to calculate. Calculate the power of its engine in kilowatts. All right, so I have velocity, I have force, and I have power. Remember that I just told you that there's a relationship between force, velocity, and power, and that relationship is this. Force is equal to power over velocity. That's the relationship that I just showed you. So if you look at this formula now, I have velocity, I have force. I don't have power. So power is the unknown, right? So if I put in those values, force is 200 Newton. 200 Newton is equal to unknown power divided by 40, which is your velocity. So the next thing you do now is to, you cross multiply to make power the subject. If you cross multiply, you're going to have power is equal to 200 times 40. 200 times 40, that should give us 8,000. Power is equal to 8,000. The unit of power is watt. But if you look at this question, they say you should calculate the power of the engine in kilowatt. So you have to convert this watts to kilowatt. And one thing about exams is this. You discover that this 8,000 will be part of the option. And it's the wrong answer because they said in kilowatt. This is in watt. So if you just see 8,000 and you choose it, you have just done nothing. It's as the same as not even answering the question at all. So calculate the power of this engine in kilowatts. So how do you convert from watt to kilowatt? You divide by 1,000. So 8,000 divided by 1,000. So which means in kilowatt, the answer will be 8 kilowatts. 8 kilowatts. Do we see that? Hello, are you with me?
Yes, sir.
Okay, okay. Do you understand what I've just done?
No, sir. Please come again. I don't understand.
Okay. From which part?
Sir, you say we should calculate the power in it. But how do you get force equals to power over velocity?
I said that is the relationship between force, power, and velocity. There's a relationship between those three. That is the formula connecting them. That is what I mean. That okay, see, at the beginning, I've already shown it here. As I told you to take note of this. Maybe you did not hear me or you did not write them down. Because I told you that we are going to use this now in today's class. I want you to write this down. That was what I said. Okay,
Okay, sir. I
so
write
you
it
can
down.
see now, you wrote it down. All right, is
Yes,
that
yes,
first one that I used. Force is power over velocity. And if you now look at this question, they gave you velocity of 40 meters per second. The unit of velocity is meters per second. So which means velocity is 40 meters per second in this question. Force is 200 Newton, and the question is asking you to calculate power. You are seeing velocity, force, and power. What comes to your mind is that relationship. You have to memorize formulas. That is just the truth. So that when you have values like this, you have to think, okay, which formula connects these values together? And before you know it, you have solved the question. Okay, so force is power over velocity. I substituted the values. Power is unknown, is the one we have to calculate. But force is 200. 200 is equals to power over 40, since 40 is the velocity. Do you understand it now?
yes, yes.
Okay. Who else doesn't understand? Okay, let me give you a question. Let me give you a similar question now. Should I? Can you attempt a similar question?
Yes, sir.
Okay. Uh, a boy. I want you to write it down. Right now. Let me. Okay, so let me try and type it here. A boy running at, let's say, uh, running at 25 meters per second. Running at 25 meters per second expends. To expend means to exhaust, right? Expends a power of 100 watt. Calculate the force. Calculate the force. A boy running at 25 meters per second expends a power of 100 watt. So I've given you, okay, let me even allow you to calculate it. Or calculate and tell me your answer now. You have to calculate force. Twenty-five meters per second. and I'm giving you power 100 watts. Calculate the force. You have only 1 minute.
Sir.
Five.
Hello, are you saying something?
I said, good evening, sir.
Okay, your answer, right? Evening, how are you?
5 Newton.
Okay, your answer
Fine,
is
sir.
5 Newton. Okay, I'm waiting for the rest. What's your own answer? Azim, have you calculated your own? What's your answer?
I just
Sir,
now, sir.
Okay, 5 Newton.
Are you sure? Hope you are checking. Are you sure it's 5 Newton? Check very well.
4.
Sir, what is the question? The question showing on the screen.
Okay.
Sir.
A boy running at 25 meters per second expends a power
Yeah.
of 100 watts. Calculate the force.
It's 5.
Okay, it's no longer 4. I mean.
The boy running at 25 meters.
4. 4.
5, 4.
Give me 0.25.
Okay,
Hello,
you
sir.
have 0.5.
0.25.
Okay, check very well. How did you do it? Check the formula. Are you sure your substitution is correct? Check the formula and check the values you placed in the formula.
Okay, it's 25. Oh. That is 4, sorry. I was using 20.
You see why you should be cross-checking
The
your
answer is 4
answers.
Newton, sir.
Okay, I'm waiting for Adamu. Adamu, we are waiting for you. What's your answer? After checking, check. Please, everybody cross-check whatever you have done. Make sure you did not make any mistakes somewhere. I'm with you. I'm with you.
I said the answer is 4 Newton.
I heard you. I said cross-check.
Sir.
Yes.
Sir. The answer is 4 Newton.
Okay, but let's solve. Let me solve it now. It's taking too much time. Now, the question says that the boy is running at 25 meters per second. So your velocity will be 25. Then you are not given force. Force is unknown, is the one you are asked to calculate. Force is unknown, but you are given power as 100 watts. So, and force is power over velocity. We have already used that relationship before. Force is power over velocity. Okay, so force is equal to be 100 watts. So 100 divided by velocity. Velocity is 25. So the question is not supposed to be hard. 100 divided by 25 will give you what? Answer me. 100 divided by 25 will give you what?
4.
4. Yes, correct. That's a 4. 4 Newton. So it's just a matter of substitution. Substitute whatever value you are given correctly. Correctly. Look at it word for word. Which one is power? Which one is velocity? That's all. Power over velocity. 100 over 25. 4 Newton. Okay, so those of you who got 4 is correct. Please, if you made mistake, hope you understand it now. Hello, hope everybody is following.
Yes,
Yes,
sir.
sir.
Okay, so let's try another question and see. Let's try another question. A machine lifts a 200 kilogram object through a vertical height of 50 meters. Calculate the power of the machine. So you look at the values. A machine lifts a 200 kg. The 200 kg tells you that you have mass. Okay, so I want to bring out my values now. Mass, that is mass M, is equal to 200 kg. Through a vertical height, okay, you have been given height h, 50 meters. 50 meters, please. 50 meters. Okay, and they are supposed to give you time. Let's say in 15 minutes. Calculate the power of the machine. 50 meters. Okay, then time t, 15 minutes. But when you are dealing with stuff like this, you have to convert your time to second. So I have to convert it to second. How do you convert from minute to second? You multiply by 60. Am I right?
Yes, sir.
Are you with
You're
me?
right, sir.
Okay, 15 times 60 would give me what? That is
15 times
900
60
seconds. Yes,
is 200 by
900
10.
seconds.
200.
So I have mass 200 kg, I have height 50 meters, I have time 900 seconds. And the question says calculate power of the machine. Now you remember that power is equal to
NGH.
energy over time. Work done over time. Or and we said that energy or work done can be force times distance. Do you still remember? Force times distance. You still
Yes.
remember this, right? So energy is force times distance. So power can be force times distance over time. Now, if you look at the question, we are not given force, but we are given mass. We are given mass. So let's calculate mass. Let's calculate the force first. Force is equals to mass times acceleration. Mass times acceleration. I want you to be following me very well. You know, physics is just a matter of connection. Be able to connect what you are seeing. Okay, so force is mass times acceleration. If you look at the question carefully, you discover that it's a vertical. On the floor, it will be acceleration due to gravity because any vertical motion, that is, if you are dealing with a motion that is up or down motion, it is under the influence of gravity. It is under the influence of gravity. So the acceleration will be acceleration due to gravity. So the force in this place now will be acceleration due to gravity. The acceleration here. So which is usually 10 meters per second square. You know it's a constant, right? Acceleration due to gravity is approximately 10 meters per second square. So you are still with me, right?
Yes.
So force now is equal to, the reason why I had to calculate this force because I need it in the formula. That is mass 200 times acceleration due to gravity is 10. 200 times 10 will give me 2000 Newton. So I go into this formula. First is I can replace it with my 2000 Newton. Distance, first time distance. Distance is what? According to the question, distance is what? 50
The height.
meters. Are you still following me?
Yeah.
So time is 900. So that is 2000 times 50 over 900. What are we going to have? 2000 times 50 will be
1.111.1.
I think 100,000.
111.111.
Okay, you've already divided, right?
Yes.
You said it's 111.
Point
Point.
1111111.
Okay. So we can just say the answer is 111 watt. Okay. Please, who doesn't understand what we have just done? Hello.
Hi.
Okay, please, if you have any question from what you have just done, I want your answer. I want your question before I give you my own question. Ask. If you don't understand any part. Okay, no question. So I want you to solve this for me. Are you with me?
Yes, sir.
Okay. So in place of that, who is making noise there, sir? Where is the noise coming from? Okay, so this is my question. In place of that 200 kg, I want you to put 50 kg there, 50. So a machine lifts a 50 kg object. A machine lifts a 50 kg object through a vertical height. 50 kg, don't forget. Change that 200 to 50 kg through a vertical height of 15 meters. 15, 1-5, okay? 15 meters in 5 minutes. 15 meters in 5 minutes. 15 meters in 5 minutes. Calculate the power of the machine.
$25 watts.
Are you sure? Okay.
Yes,
Can you say
Yes, I said
the
the
height is
machine
50
50 kg, the mass is 50 kg. The height is,
yes.
which height did I give, Precious? What's the height?
15.
Yes, 15 meters,
15.
and then time 5 minutes. Time 5 minutes.
So the answer is 25.
No, say your name, write your name, and then write the what, write Gabriel, write this
Please,
as
who is disturbing us? Who is disturbing us?
sign yes, correct.
Precious, the answer is 25 watts,
Right?
right?
Right in my name.
Yes.
Right LeBron name.
I think much.
Okay, somebody said something. Yes. Your answer is what?
Okay, fine. I think 25.
And right your own name.
Are you listening?
And what
I
time
can't hear
of
you.
course.
Who is there? Let the person off his mind if he's or mine. Sir, who is? Sir, I said 5 what?
5 watts.
Yes, sir.
Cross check, cross check, cross check. Check your values, whether you place them very well. You have to calculate first. What was your first? First you calculated, what did you have? Yes, 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 yes. We have to move on. Okay. Let me solve it. Well, if you want to calculate force now, force is mass times acceleration.
Sir, it's 25. Oh.
That will be 50 times 10. That will be 500 Newton. So force times distance will now be 500 times 15. So power will now be 500 times 25. It's 25. That's 500 times 15 divided by time. Your time was given to be 5 minutes. You convert it to seconds. 5 times 600. 5 times 60 will give you 300. So if you now divide 50 times 15 divided by 300, so it will give you 25. It will give you 25. Okay, so who's above the ground? Calculate the kinetic energy just before hitting the ground. So it's just English. They are just speaking English. They calculate kinetic energy is enough. That's all. They are giving you the mass of the object. They said they're giving you the height. They're giving you time. Okay, and you see now how technical these examiners are. They are very logical. So let me solve it so that you will see. Solution. They want me to calculate kinetic energy. And this object was released from a height. You know, before you calculate kinetic energy, you need to have velocity, okay? You need to have velocity, okay? So because kinetic energy is half mv square. Kinetic energy is half mv square. So if you look at the question, you don't have velocity in the question. You have mass, you have height, you have time. So remember that I stated before we started this class, I said that, please, are you with me?
Yes, sir.
Hello. Okay. I said that kinetic energy is equal to potential energy according to the law. The kinetic energy of a body is equal to its potential energy. Okay, according to the law of conservation of energy, you know that energy can neither be created nor destroyed, or can be transformed, can be changed from one form to another. That is the law of conservation of energy. Now, kinetic energy is equal to potential energy. So if I apply that law here, if I apply that law of conservation, let's see whether I'll be able to get my answer. You know, they have given you mass, they have given you height, and you know that this is a vertical motion. This is a vertical motion because the object is released from a height. The object is released from a height. It's a vertical motion. What is the formula for potential energy? Mass times acceleration due to gravity times height. That is the formula for potential energy. Okay, so that's what I'm going to use now. Mass times acceleration due to gravity times height. So I'm going to equate them according to the law of conservation of energy. I'm going to say Ke. I'm just going to obey that law. That is all. Ke is equals to Pe, which is equal to mgh. Why am I using mgh? Because if you look at the question, I was not given velocity. So if I was given velocity, I would have just used the half mv squared directly. So my work now will be 50 times acceleration due to gravity is a constant. It's always constant 10. Then height. Height was given to be 5 meters above the ground, 5 meters. Okay, this is it. So that is 50 times 10 times 5. What are you going to have? That is 500 times 5. That is 2,500 joules. Very simple. You have calculated it. It's as simple as this. So remember that law of conservation of energy. Okay, kinetic energy is equal to potential energy, because you will see many questions in physics that you will need that relationship to be able to solve them. Okay, kinetic energy is equal to potential energy. So I've just solved the question now. It's as simple as this. Any confusion?
Yeah.
Yes.
What of his time? Why do you not make use of the time?
They can give time, but you don't need it. You don't. It's not everything that's given the question that you need to answer a particular question. You will not need it. Yeah, that's why I'm mentioning that there are some things you have to put in mind. If you know the values you have and what they are asking of you, they are asking you to calculate kinetic energy just before an object. This object was released from a height, which means the object was initially at rest. Okay, so and now it was released. It has potential energy, but now it has kinetic energy. And according to the law of conservation of energy, the potential energy will be equal to kinetic energy. That is all you need to solve the question.
Okay.
Is that okay?
Yes, sir.
All right. Okay,
So
let
please
me
ask the question.
yes, yes.
Should I ask?
What do you say?
I said I want to ask a question. Should I ask?
Yes, yes, ask your question.
So please, when kinetic energy equals to potential energy, is it before the object moves that kinetic energy equals to potential energy?
Before the object moves, kinetic energy is zero now. There is no kinetic energy before the object moves. An object that is just about to move has only potential energy.
Okay, when the object has started to move, kinetic energy equals to potential energy.
Yes.
Okay, sir.
Or especially when it's just about hitting the ground. You know, there's okay. I'm actually assuming that you guys are supposed to be familiar with this. You know, when an object is at a particular height, at that height, that object does not have kinetic energy. But once that object begins to move, it gets to a point where kinetic energy is equal to potential energy, especially when the object is just about to strike the ground. The kinetic energy and the potential energy will be equal. Because after it has rested, if the object is now on the ground, it means the kinetic energy is no more. There's no kinetic energy again. That is why the question says just before hitting the ground. That is how they normally ask the question. So, but if the object has not started motion, there is no kinetic energy. So at the point where the object
Okay,
is
sir.
in motion, yes,
So you mean that just before the ball hits the ground, if they say that just before it hits the ground, that means they are indirectly telling us that kinetic energy equals to potential energy there.
yes, yes.
Okay, sir.
All right. let me give you this question, right? A ball, that is football now. A ball of a ball of 25 kg is released from a rest. Is released from rest. If the kinetic energy, if the kinetic energy is 500 joules. Calculate the height. Calculate the height from which the ball was released. Calculate the height from which the ball was released. A ball of 25 kg is released from rest. If the kinetic energy is 500 joules, calculate the height from which it was released. Very simple. They have given you mass. You have been given kinetic energy. So they want you to calculate height. You have 1 minute, 1 minute, 1 minute.
That's true.
Okay.
2
Yeah,
meters.
true. What's the answer?
2 meters.
2 meters. Okay. Yes, I'm waiting for others. Azim, Adamu. Mass
Sir, 2 meter.
is 25 kg.
Sir, 2 meter.
Kinetic energy is 500 joules. So they are asking for height. And the type of energy that contains height is potential energy. So they are, you see, over that doesn't know where you are.
Yeah.
Yes,
Yeah.
yes, I'm with you. I'm with you. Ask your question. Ask your question.
Download that in the morning.
Yeah. I've understand. No problem.
Are you sure? Are you sure? Are you very sure? Hello. I expect your reply. You wanted to ask a question. You did not ask. Are you sure you understand now? Okay, let's move on. Let me give you something simpler before we even get into the other one. So this is another question. This one says a boy drags a table on a horizontal floor through a distance, a horizontal floor through a distance. You have been given the distance to be 1.5 meters with 20 Newton force. So what you have here now is you have distance, you have force. Okay, just get your values down. Distance is equal to 1.5 meters. Force is equal to 20 Newton. Angle, they gave you angles. Theta, angle as theta. Angle is equal to 45 degrees. So the question now says you should calculate work done. Question is asking for work done. So I've said something about this at the beginning of today's class. So which formula are we going to use now? Which formula are we going to use?
Work is equals to force times distance times cos theta.
Yeah, correct. Force times distance times cos theta. That's all. Once you have written
Sir,
your formula, yes,
yeah. Is it that this
yes,
cos
I'm
like
with
like
you.
the angle is always cos because there's this one that is also
Yes,
sine.
it depends on if the work, if it's an inclined plane. If you are dealing with an inclined plane, that is where you talk about somewhere will be sine, somewhere will be force. So we might still get there,
Okay.
okay? This one
Okay,
now
sir.
says the object is dragged on a horizontal floor. So you are dealing with a floor. It's a horizontal motion, not an inclined motion.
Okay.
So force is 20. Distance is 1.5 times cos theta. My theta is 45. Cos 45 will give you what, please?
0.71.
Okay. 0.7. So multiply everything. Use a 4 decimal places for that cos 45. 0.7 what?
Income 0.7071.
So
The answer is 30.7071.
okay, 30.7 is okay. 30.7. What do you need for work?
Mm,
What's the unit?
Joe.
Joules. It is the same as the unit of energy. Okay, joules. All right. Ask any question. Ask your question if you don't understand. Ask your question if you don't understand. Okay, so let me ask my question now. So this is my question. So forget the long English. The distance now. Let's say the distance is, I'm giving you of 500 centimeters.
Anita,
500
sir,
centimeters. 500 centimeters. Yes.
sir, please, are you listening to me?
Yes, I'm listening to you, Azim.
Sir, please, I calculated mine. Yeah. The answer was
What?
21.21. I calculated mine. The answer was
Hey,
21.
so is one of you that called it for me? Oh, I don't have calculator here, so I don't know. 20
Tell
times
you that it is
1.5.
Check it here now. Plus 45, right?
Yes, cos 45.
Yes, cos.
Cos 45. Is it not? It's 0.7071 now.
Now multiply everything together.
Yes.
Let's see what you have again.
Times 20 times 1.5.
Yes.
The answer is 30.7.
And 45 times.
Please check your calculator very well, guys. Check your calculator. I hope it's in degrees.
70.71 times 1.5. I saw my own calculator is in degree now, and I'm getting
It's not supposed to
21.2.
be in degree now.
Yes, it's in degree. It's
It's
not in
not supposed to
radian, it's
be
in
in
degree.
degree.
I'm sorry. It's not even scientific calculator. I'm not even using scientific calculator. It's normal calculator that I'm using.
Okay. Precious. Hello, Precious. So tell
Yes,
me,
sir.
20 times 1.5. 20 times 1.5. What do you have?
Like
30.
Okay, 30. 30 times
30 point.
0.7071.
Yes.
30 times 0.7071.
30.7071.
No, wait now. 30 times 0.7071. It's not plus now. It's not plus. It's times.
It's 21.02.
Okay, I'm waiting for Precious.
Okay.
What do you have? Are you still
Okay.
with us?
21.21.
21.2, are you sure?
Yes.
Guys, is it 21.2?
21.213.
All right, so 21.2 joules. Okay. I said I was stating your own question. Now let me give you your question now for everybody to solve. I said change the distance to 500 centimeters. Change the distance to 500 centimeters. And the force to, let's say 10 Newton. The force 10 Newton.
Sir, please come back.
Okay, distance 500 centimeters.
Mm.
So are you
Force,
calling the question?
what
Sir,
did you say, Azim?
are you
Yes.
calling a question?
Yes, I'm
Yes.
Sir,
stating a question, okay?
please restate it, sir.
Okay. Hey boy, I'm still using the same statement, okay? I'm just changing the values that are here in the question. Is that okay?
Eh,
Okay.
Okay. Distance. Adam, yes. Do you want to ask a question?
you see distance 500 centimeters.
Yes. Okay, let me write that. Some of you are confused. A boy, let's say a boy runs. Okay. A boy drags an object through a distance of 500 centimeters at with a force of 10 Newton acting at an angle with the horizontal floor. If the work done If the work done is 20 joules, if the work done is 20 joules, calculate the angle of the force. That's the question.
Mohammed. Mohammed.
So can you answer now? In this question now is angle, you have to calculate. You have to calculate angle.
Mohammed. Ṣé wọ́n sọ fún mi bọ́ọ̀lù káàmì mẹ́rin? Owó tó ṣe jáde ibẹ̀ ló wà tẹ́lẹ̀. Mohammed. Ṣé ó lọ ra nǹkan ni?
Okay, I'm waiting. Distance 500 centimeters. Please don't make a mistake. It has to be in meters. The distance has to be in meters. So you have to convert.
Mo ti kú àwọn oníyòó lè ó máa padà sí ìdálẹ̀
Mute yourself.
ìdálẹ̀ máa pa wọn.
I think the answer is 0.4.
Angle. Are you sure?
No,
Angle.
no. Minus no. Shift. $66.42.
Okay, you have 66. Okay.
Yeah.
Yes.
It's giving 66.4.
66.4.
Okay. So which means you did cos inverse. Is that also?
Yes.
Good. Because if you do not do cos inverse, you're not going to get it. All right. And you can see in exams, you can put that 0 point something that you have without doing cos inverse. They'll put it as part of the option. And they'll put this 66 point something also as part of the option. Some people will choose that 0 point something. That is why it is very easy to pass. It's very easy to fail. Okay. So I have 20 is equal to, yes, everybody should confirm. I hope it's 66 point something. Nobody has something different, right?
No.
All right. Okay. If nobody has something different, let's move on then. So another question. So I want somebody to attempt. Guys, attempt this one. You should be able to. Attempt this one. Engine has a particular power. The car is moving at per second. And calculate force.
5.
5 what? 5 naira.
No.
So 5 watts.
5 Newton.
Good. So they are giving you power at the 50 kilowatt. Did you convert the kilowatt to watt? You're supposed to convert before you use power to solve. You have to. It must always be in watt. So that's 50,000 watts. So check it and do it
The
again now.
answer will be 5,000. Yes, 5,000
Okay.
Newton.
Let's wait for the rest and see what they have to.
5,000
Guys,
what?
what do you have?
5,000 what?
5,000. Are you sure it's watt? It's
Newton.
not power you have to calculate. Force. You are
5,000 Newton.
calculating
So
force. Good. 5,000 Newton. 5,000 Newton. Okay, let me give you more questions now. But these ones are not here. Let me pick them from. I'll have to be stating them for you from the JAMB series now. Is that okay? And I will give you the options. Then you choose the correct option. Is that fine?
Yes, sir.
Okay, so I'll have to. Hello, guys. Is that okay with you?
Yes, sir.
Okay, I'll have to stop sharing my screen. Okay, so I will be stating the question from here. So listen very well. Oh, you know we don't have much time. You have to listen very well and be fast. Please learn to beat time and also learn to be accurate. Beat
So are
time
you dictating it or
and
you are sharing your screen?
yes, I'll dictate it. I'll dictate it. Just be listening to the values. I'm coming. I'm even
Okay.
looking for that series. Okay. So listen. How long? They're asking for time now. Hello. How long will it take a 60 kg, a 60 kilogram man? Okay, I told you to be listening to the values. How long will it take a 60 kg man to climb a height of 22 meters if he expended 0.25 kilowatts? Let me go again. How long will it take a 60 kilogram man to climb a height of 22 meters if he expends 0.25 kilowatts? They're asking to calculate for time. Are you true? Are you true?
Yes, sir. Positivity might be charged 528 seconds.
528. Are you sure it's 528?
So what do you call the mass?
60 kg.
Okay.
Precious, what do you have?
Sir, I'm not sure yet.
Okay. You have mass, you have height, you have power. Don't forget, height is the same thing as distance. Vertical height is the same thing as distance, okay? If it is vertical, you call it height. If it is horizontal, you call it just distance. So they have given you mass, they have given you height or distance, they have given you power. But you have to convert that your power from kilowatts to watt. And acceleration due to gravity, in case you need it, is 10 meters per second square. Should I solve it?
It's giving me 51.7.
Okay, you have what?
51.7.
Okay, 51.7. Check it very well. Check it again. Check it. Okay, check it.
Sir, please give us the option. Let's compare.
Okay, want to compare option A 5.3 seconds, B 34.5 seconds, C 41.6 seconds, D 52.8 seconds. I've given you the options.
Okay.
Let me share my
I
screen
mean,
so
I'm
that I can
getting
solve it. You are getting what, please?
528.
520. Did you convert that power? Did you convert it from kilowatt to watt?
Yes, it's 25
Okay.
now.
Are you sure it's 25?
Yes, sir.
Okay. If you multiply by 1000,
Yes, sir. I
if you
think it's from
multiply,
the 0
don't
point.
think, oh, wait. 0.25 times 1,000. Are you sure it's 25?
So is it 0.25 or be 0.025?
It's 0.25.
Ah, no. I'm just having different things.
'Are we through?
52.8. Yes, sir.
Okay, 52.8 seconds. Yes, I'm waiting for others. Azim and Adams. Azim and Adamu, let me hear your own. Okay, before they return, maybe they went somewhere. Before they return, Precious, calculate another question for me. Are you there?
Yes, sir.
A car traveling at 60 meters per second. A car traveling at 60 meters per second produces a force of 400 Newton. A car traveling at 60 meters per second produces a force of 400 Newton. Calculate the power of the engine. Calculate the power of the engine in kilowatts. In kilowatts.
Sir, please repeat.
A car
Say the
traveling,
parameter again.
okay, 60 meters per second
Mm-hmm.
produces a force of 400 Newton.
Yeah.
Calculate the power in kilowatts.
24.
Correct. That's good. Very good. Option A here is 25, option B 22, option C 24, option D 20. That's great. Okay, let me give you one more before we stop. Should I?
Yes, sir.
Okay. A man weighing 800 Newton. A man weighing
Mm-hmm.
800 Newton climbs a flight of stairs to a height
Mm-hmm.
of 15 meters,
Mm-hmm.
in 12.5 seconds. 12.5 seconds. What is the man's
12.5.
average power? Seconds. What is the man's average power output? They are just asking for the power. That's all.
Sir, I do not get it.
A man weighing 800 Newton
Yeah.
climbs up a flight of stairs to a height. Height is 15 meters
Yeah.
in 12.5 seconds. 12.5 seconds. That is time. Time is 12.5 seconds now. What is the man's average power output? They ask you to calculate the power expended by the man. That's all.
Hmm.
Are you confused by them using weight there? Are you confused?
Sir, let me just try something. I don't.
Force times distance over time, that is all now. Your force is the 800. That weight will act as your force. Since it's in Newton, that is 800 times 15 divided by 12.5. So try it and tell me what you have as your answer. All right. Hello. Are you through? We are rounding up now.
Yes, sir.
800 times distance over time. They have given you distance too. What will be your answer?
Sir, come again with the formula. Sir. Sir,
Yeah.
please come again with the formula.
Power is energy over time now, or force times distance over time.
Yes.
I said that weight there will represent you
Three force
Newton.
times
So,
distance
and
is
you are given
15.
800. Are you true now?
960. Well, let me try again. Yes, 960.
All right, correct. Okay, we've come to the end of today's class. See
Okay,
you
sir.
in the next class.
Yes. Thank you,
All
sir.
right. Have a wonderful night. Yeah.
Okay.
Hey, Suma, Suma did not send this one. Hey,